Before we begin, make sure you follow this channel because today we're diving into a story so massive, so universe-shattering that it will completely change how you think about reality itself. Imagine spending your entire life looking at the night sky, believing the stars are the whole story, only to discover that the real universe is something else entirely, something invisible, silent, and overwhelmingly powerful. Imagine realizing that everything humanity has ever believed about the cosmos might be wrong. Now imagine being the person who uncovers this truth and still being ignored. That person was Vera Rubin, the woman who discovered that the universe is held together by a force we still cannot see, cannot touch, and cannot fully understand. A force that makes up more than 85% of all matter in existence. A force so dominant that without it, galaxies would fly apart, stars would drift into the void, and the universe as we know it would collapse into chaos. And yet, the world refused to listen. But the story begins long before Vera Rubin looked through her first telescope. It begins with a girl who stared out her bedroom window at the moving stars, whose curiosity was dismissed, whose intelligence was underestimated, and whose passion for astronomy was considered unladylike. Born in 1928, in a world where women were expected to become teachers, secretaries, or mothers, not scientists, Vera grew up with a kind of mind that couldn't stop asking questions. She wanted to know why galaxies swirl, why stars cluster, why space behaves the way it does. She wanted answers the universe wouldn't give easily. Even as a child, she noticed patterns most people overlooked: how stars shifted, how constellations twisted through the seasons, how the night sky was full of secrets. But society didn't appreciate curious girls. Her teachers told her she was too ambitious. Her college applications were discouraged. Her dreams were dismissed. But the universe doesn't care about human expectations, and neither did Vera Rubin. She pushed forward, fought to study astronomy, and found herself in a world overwhelmingly dominated by men. Men who believed women simply did not belong in scientific research. Men who believed physics was too complicated, telescopes too demanding, theories too masculine. At Princeton University, women were not even allowed into the graduate astronomy program. Not because they were unqualified, but because the university simply had no intention of teaching them. The admissions brochure literally stated, "Women are not accepted." But Vera Rubin didn't stop. She found another university, got her degree, and began studying the thing that had always fascinated her: the motion of galaxies. Everyone else was focused on bright stars, black holes, nebulae, things that were dramatic and photogenic. But Vera wanted something different. She wanted to understand the structure of the universe itself. Galaxies, those massive spirals of stars, were her obsession. But studying them was difficult, tedious, and often dismissed as unimportant. Most astronomers believed galaxies behaved like solar systems. Most of the mass at the center, stars orbiting slower the farther they were from that center. It was simple, elegant, and widely accepted. Except it was wrong. Vera Rubin didn't set out to challenge the foundation of astronomy. She simply followed the data. With her colleague, Kent Ford, she began measuring how fast stars and distant galaxies were moving. It required long nights, heavy equipment, and grueling calculations. It meant sitting behind early spectrographs, recording faint patterns of light onto photographic plates, and analyzing them carefully by hand. And what she found was shocking. The stars at the edges of galaxies, where gravity should have been weakest, weren't slowing down. They were moving just as fast as the stars near the center. This made no sense. According to Newtonian physics, those stars should have been flung into empty space. The galaxies should have been tearing themselves apart. Something was wrong. Something was missing. Something massive, invisible, and everywhere. Vera Rubin had discovered the first evidence of dark matter. Now imagine making a discovery so enormous that it rewrites the laws of physics, and no one believes you. Rubin presented her findings. She showed the curves. She showed the data. She showed the impossible. And the men in the room refused to accept it. They laughed. They dismissed her. They said her instruments were flawed, her calculations incorrect, her conclusions absurd. They said galaxies simply couldn't behave that way. They said her results were interesting, but surely a mistake. They said they would believe it when a man confirmed it. But Vera was not wrong. Night after night, telescope after telescope, she gathered more data than anyone before her. And every galaxy told the same story. The universe was full of unseen matter, matter that didn't shine, didn't reflect, didn't emit light. It was everywhere, shaping everything, holding the cosmos together like an invisible web. She showed the data again, and again, and again. And finally, the scientific world was forced to confront the truth. The universe they thought they knew was just the tip of the cosmic iceberg. The stars, planets, nebulae, everything we see are just crumbs. The real universe, the massive universe, the dominant universe, is dark. Vera Rubin had pulled back the curtain on the greatest hidden structure in existence. But recognition did not come easily. Awards went to others. Credit went to men who built theoretical frameworks. Her discovery was too big, too disruptive, too uncomfortable for the establishment. For decades, the Nobel Prize Committee ignored her work, despite nominations, despite her discovery being one of the most important in the history of science. Even today, cosmologists rely on her rotation curves. Researchers build theories on her findings. Dark matter is the foundation of modern astronomy. And yet, Vera Rubin never received the Nobel Prize she deserved. But what she did receive, what no one could ever take away, was the legacy of someone who changed the universe without ever seeking fame. Rubin was quiet, humble, kind, and endlessly patient. She wasn't interested in glory. She was interested in truth. And the truth she found is bigger than anything we can comprehend. Today, dark matter dominates our models of how galaxies form, how cosmic structures grow, how the universe evolves. It explains why galaxies rotate, why clusters move, why gravity behaves the way it does. It is the invisible scaffolding of reality. And without Vera Rubin, we might never have known it exists. Her discovery reshaped cosmology, astrophysics, particle physics, and the entire field of astronomy. She revealed the unseen. She illuminated the dark. And she forced humanity to confront the fact that we understand almost nothing about the universe we live in. But that is only the beginning of her story. Because the road that led to this discovery is filled with obstacles, rejections, moments of doubt, and moments of breathtaking brilliance. This is not just a story of science. It's a story of persistence, resilience, and courage. It's the story of a woman who saw the universe differently while everyone else refused to look. And today, we're going to follow her journey from a curious child watching the stars to the scientist who proved the cosmos is built on mystery. So stay with me, because what happens next is even more unbelievable. Vera Rubin didn't just discover dark matter. She discovered something far deeper about the universe and about humanity's place within it. As Vera Rubin pushed deeper into the mysteries of the cosmos, she realized she was stepping into territory no one else dared explore. A region of scientific wilderness that would either destroy her credibility or redefine astronomy forever. Every night spent at the telescope, every faint curve of light she pulled from distant galaxies, every chart she built by hand brought her closer to a truth she could feel but could not yet prove to the world. She knew that if her findings were correct, they would force astronomers to dismantle decades of assumptions and rebuild their understanding of the universe from the ground up. But the resistance she faced was relentless. Rubin was operating in an era where women in science were treated as intruders. They were expected to be quiet, supportive, invisible, and certainly not revolutionary. Yet here she was, on the brink of revealing that 85% of the universe was missing from the equations of men who claimed they had everything figured out. Her work at the Carnegie Institution became both her sanctuary and her battlefield. On one hand, she had access to instruments capable of reaching out into galaxies millions of light-years away. On the other hand, she constantly had to justify her presence, her intelligence, and her results. It wasn't just that her data was controversial. Her very existence in the field was an act of defiance. Observatories, historically, were built like temples of male intellect, and Rubin often had to navigate spaces not designed for her. Some observatories had no women's restrooms. Others barred women entirely. One even told her to enter through the back door because women were not allowed near the main entrance. But the universe didn't care about these restrictions, and Rubin refused to let human pettiness limit her reach into the stars. She kept gathering rotation curves, graphs that plotted the speeds of stars as they moved around their galactic centers. What she found was shocking in its consistency. Every galaxy she examined disobeyed the rules. The stars on the outer edges moved too fast, as if pulled by an unseen hand. The gravitational pull required to keep those stars in orbit simply didn't exist if one only counted visible matter. It was as though the universe itself was whispering that something massive was hidden beneath the surface. Rubin's early results came from Andromeda, the closest spiral galaxy to our own. Traditionally, astronomers believed that galaxies behaved like oversized solar systems, slow on the outside, fast on the inside. But Andromeda didn't follow that rule. Its rotation curve was flat. Stars far from the center weren't slowing down. They were racing. Rubin checked the data again and again. She rebuilt the charts by hand. She recalibrated the instruments. She checked for errors in the plates. Nothing changed. And then she studied more galaxies, hundreds more. All of them behaved the same way. If Rubin was wrong, then the entire universe was wrong with her. The resistance she faced grew louder. Her discovery didn't align with the elegant, clean theories of physicists who believed the universe was understandable, predictable, and tidy. Rubin's work suggested the exact opposite. That the universe was dominated by something invisible, something mysterious, something none of them had ever considered seriously. Critics argued that her methods were flawed. Others insisted galaxies must contain hidden clouds of normal matter, dust, gas, rocks that simply hadn't been detected. But Rubin knew the math. If galaxies were filled with hidden clouds of normal matter, they would block light, distort starlight, and emit heat detectable in infrared. But they didn't. Whatever was out there wasn't normal. It didn't behave like atoms. It didn't act like any form of matter known to physics. It was dark, truly dark. Not merely dim, not merely hidden. Dark in the purest sense of the word. Matter that did not interact with light at all. She was looking at something completely outside the standard model of physics. Something that should not exist, yet clearly did. Meanwhile, the academic world continued to treat Rubin like a curiosity rather than a revolutionary. When she spoke at conferences, men often ignored her results or talked over her. Some dismissed her with patronizing smiles. Others weaponized technical jargon to undermine her conclusions. But the data was undeniable. And slowly, the cracks in the old worldview grew. Younger scientists, open-minded and eager for truth, began to pay attention. They saw the rotation curves. They saw the consistency. They saw the impossibility of denying her results. Rubin's discoveries began to ripple outward, affecting theories about galaxy formation, cosmic evolution, and the structure of the universe. Astrophysicists realized that without dark matter, the early universe could not have formed galaxies at all. Without dark matter, the cosmic web, the vast structure of filaments and voids spanning billions of light years, would not exist. Rubin wasn't just studying galaxies, she was rewriting the creation story of the cosmos. But human recognition came painfully slowly. Rubin pushed forward anyway. She collaborated, mentored young scientists, and became a role model for women who had been told that astronomy wasn't meant for them. And she did it all with a quiet determination, free from arrogance or bitterness. She often said, "Science progresses one funeral at a time." She knew that many of her harshest critics would never accept her work. But she also knew future generations would build on it. She wasn't trying to win an argument. She was trying to reveal the truth. One of the turning points came when Rubin began mapping the rotation curves of entire clusters of galaxies. These massive structures, containing hundreds or thousands of galaxies, moved in ways that made no sense if one only considered visible matter. They moved as if ghosts, vast, invisible gravitational ghosts, were pulling the strings. Her results aligned with the earlier, largely ignored work of Fritz Zwicky, a Swiss astronomer who decades earlier had suggested the existence of missing mass. Rubin's work confirmed what Zwicky had suspected and elevated it from speculation to undeniable fact. But Rubin didn't simply confirm dark matter. She measured it. She mapped it. She showed that dark matter enveloped galaxies like enormous halos. Not like disks, not like clouds, not like rings, but halos. Massive, spherical, invisible cocoons stretching far beyond the bright, star-filled regions. Dark matter wasn't something galaxies contained. Dark matter was something galaxies lived inside. This single insight transformed cosmology. The galaxies we see, the glowing spirals and brilliant cores, are just the tiny, visible centers of much larger, much heavier structures. The universe is not made of stars. It is not made of gas. It is not made of planets. The universe is made of darkness. Rubin had uncovered the skeleton of the cosmos. Yet, even as her work reshaped scientific models, she remained humble. She disliked conflict, avoided bragging, and focused on teaching and discovery. She never sought fame. She never demanded credit. Her reward was the truth itself. But the truth did not shield her from discrimination. In meeting after meeting, men would claim her co-author must have done the real work. They said dark matter was too important to have been discovered by a woman. Even after her results became accepted, awards bypassed her. The Nobel Prize committees ignored her year after year, even as dark matter became central to physics. The world recognized her work, just not with the honors she deserved. Still, Rubin pressed on, widening her research to study the large-scale structure of the universe. She found that galaxies weren't scattered randomly. They formed patterns, cosmic structures that looked like filaments, webs, and clusters. The universe resembled a vast three-dimensional spiderweb woven from galaxies, with dark matter acting as the unseen threads holding everything together. She studied dwarf galaxies, spiral galaxies, elliptical galaxies, and even galaxies warped by gravitational interactions. Every one of them carried the signature of dark matter. Every one defied the predictions of visible matter alone. Every one proved her right. And as her reputation grew, young women flocked to her for mentorship. Rubin encouraged them relentlessly. She insisted that their questions mattered, that their voices mattered, that their curiosity mattered. She believed the universe was too big to be explored by only half of humanity. Her influence extended far beyond dark matter. She became a symbol, a living reminder that brilliance has no gender. And as she stood under the stars, guiding students, explaining cosmic mysteries, she often said, "The joy of science is to wake up every morning and expect something new." That was the essence of Vera Rubin. Not the struggle, not the discrimination, not even the discovery itself, but the wonder. The endless, childlike wonder. And yet, even as she reshaped the universe, she remained grounded in humility. She said she didn't care about prizes. She cared about progress. She didn't want statues. She wanted science to flourish. She didn't want to be remembered as a rebel, but as a researcher. But destiny had other plans. Vera Rubin became a giant. The quiet woman who listened to the stars became the scientist who made the universe speak. And as her work spread across the scientific world, as cosmologists built models around her findings, As physicists began hunting for dark matter particles in underground laboratories, Rubin watched it all unfold with a gentle, satisfied smile. Her discovery had ignited a global quest to uncover the true nature of the cosmos. Dark matter became one of the biggest mysteries in science, one of the central questions of modern physics. Entire research fields were born from her work. Telescopes were built to study it. Detectors were constructed to detect it. Supercomputers simulated it. Physicists devoted their lives to it. The universe had been broken open, and Rubin had swung the hammer. Yet her story doesn't end with acceptance. It doesn't end with recognition. It doesn't end with celebration. It ends with a question, one that still haunts astrophysicists today. If most of the universe is invisible. As Vera Rubin stepped deeper into the unseen architecture of the universe, she realized she had touched something far greater than a scientific discovery. She had exposed a cosmic truth that humanity was never prepared to confront. Dark matter was not just a missing piece of physics. It was a revelation that everything we see, everything we think we understand, everything we have ever called the universe, is merely the surface of a much deeper and stranger reality. The galaxies she studied, those magnificent spirals of starlight and dust, were only decorations floating inside enormous, invisible halos. The stars we worship, the planets we dream of reaching, the glowing nebulae that decorate our telescopes, they were all prisoners inside vast spheres of unseen mass. Rubin's work showed that the visible cosmos is nothing more than a thin veneer on top of an overwhelmingly mysterious foundation. And as her understanding grew, so did the implications. If dark matter existed everywhere, then it shaped not just how galaxies spin, but how galaxies form, how they survive collisions, how clusters merge, how structures grow over billions of years. It meant the universe had a hidden skeleton, an invisible scaffolding that reached across unimaginable distances. It meant that the earliest moments after the Big Bang were driven not just by energy and light, but by this invisible matter guiding the flow of cosmic evolution. The more Rubin uncovered, the more the universe seemed to whisper that humanity was not the intelligent master of cosmic truth, but a child standing in a dark room with only a candle, seeing only what the flame allowed. Astronomers began to build simulations of the universe using Rubin's rotation curves. They found that without dark matter, the early universe would have been too chaotic for galaxies to form. Gravity alone could not have pulled enough matter together to create stars, planets, or anything resembling the cosmic structures we see today. Dark matter acted like a glue, gathering gas clouds, pulling them inward, allowing stars to ignite. It was the universe's silent architect. Rubin's discovery meant that everything humans call existence was shaped by something we cannot see, cannot touch, and cannot interact with. Something that passes through our bodies every second without us noticing. Something that fills the room around you right now, completely invisible yet overwhelmingly present. Something older than light itself. And while the scientific world wrestled with the implications, Rubin continued her work with the same calm determination she had always carried. She observed galaxies warped by gravitational interactions. She measured star velocities in systems twisted by cosmic collisions. She studied dwarf galaxies, small, dim, irregular galaxies that behaved even more strangely than their larger cousins. Dwarf galaxies are some of the most dark, matter-dominated objects in the universe. Their visible stars are like grains of sand sprinkled inside enormous halos of invisible mass. Rubin showed that these small galaxies should not even exist without dark matter. They should have been torn apart by gravitational forces long ago. Yet they survived because something powerful, something unseen, was holding them together. She studied galaxy clusters, massive gatherings of hundreds of galaxies, and found that dark matter provided the gravitational glue that kept them bound. Without dark matter, these clusters would have flown apart into empty space. Everywhere she looked, dark matter was the invisible puppet master behind cosmic structure. She realized the universe was not made of light, it was made of shadow. And yet, Rubin's personality remained the opposite of the colossal scale of her discovery. She was soft-spoken, gentle, and endlessly curious. She loved the feeling of being at an observatory on a cold night, watching the stars drift across the dome. She loved the hum of the equipment, the quiet scratching of her pen as she recorded data, the soft glow of the spectrograph as it revealed secrets from millions of light-years away. She never chased fame. She never sought scientific dominance. She simply followed the truth wherever it led. And that truth led her to something even deeper: the realization that dark matter might only be the beginning. If 85% of matter is invisible, then what about the rest of the universe? Dark matter was strange enough, but in the late 1990s, scientists discovered something even more disturbing: dark energy, a mysterious force causing the expansion of the universe to accelerate. Rubin didn't discover dark energy, but her work laid the foundation for understanding that the universe contains far more than what we can see. With dark matter and dark energy combined, humanity realized something astonishing: the visible universe. Everything we have ever known makes up less than 5% of reality. The rest is darkness. Rubin had opened the door to a new cosmic era. Scientists began to search for dark matter particles. They built underground detectors shielded from cosmic rays. They built telescopes to map gravitational lensing, light bending caused by dark matter. They built supercomputers to simulate the evolution of the universe, following the invisible filaments of dark matter that stretch across billions of light-years. But the nature of dark matter remains unknown. It might be exotic particles, it might be a new field, it might be a new force of nature. It might be something stranger than we can imagine. It might even be something that breaks the laws of physics themselves. And in every experiment, in every simulation, in every theory, Rubin's fingerprints remain. Her rotation curves are still the benchmark. Her measurements are still the foundation. Her persistence is still the reason we know the universe is mostly invisible. And yet, the world never honored her the way it should have. Rubin passed away in 2016, never receiving a Nobel Prize. Despite dark matter being one of the most important scientific discoveries of the last century. The scientific community mourned her, but many also felt the sting of regret, because the Nobel Prize cannot be awarded posthumously. Vera Rubin will never receive it. But in a way, she received something far greater. Astronomers named telescopes after her. They named observatories after her. They named theories after her. And more importantly, every time a researcher studies dark matter, every time a telescope maps galaxy motions, every time a student falls in love with the mysteries of the universe, they walk in Rubin's footsteps. Her true reward is not a medal. It is the legacy of revealing the real universe. Because Vera Rubin didn't just discover dark matter, she discovered the limits of human knowledge. She revealed that we see only the surface of a much deeper reality. She showed that the universe is far stranger than anyone imagined. And she proved that even the quietest voice can change the world. And now, as the astronomy community continues to explore the mysteries she uncovered, her story becomes a reminder of something profound. The greatest discoveries are not always made by the loudest people, but by those who keep asking questions even when the world refuses to listen. Vera Rubin looked into the dark and found the truth hidden within it. And now, it's our turn. If you want more stories of forgotten geniuses, hidden discoveries, and the mysteries that shape our world, make sure you subscribe, because the next episode will dive into a secret of the universe even stranger than dark matter, and trust me, you don't want to miss it.